Hey everyone, welcome to the Simplilearn's YouTube channel. In this tutorial, we will learn about the context window in LLMs. Understanding the context window is essential for working with large language models. It refers to the maximum amount of text or tokens a model can process at once. Think of it as a model's short-term memory. It determines how much prior conversation or content it can recall. If the input exceeds the limit, the model forgets the earlier parts and starts to hallucinate. A larger context window means better coherence, deeper understanding, and smarter responses. It's crucial for tasks like summarization, multi-turn conversation, or complex prompts. Learning how it works helps you design better prompts and avoid truncation issues. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills to land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies and academicians from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started. What exactly is a context window? Imagine two people are talking about a topic. As a typical mind's nature, the topic is prone to get forgotten after a brief period of time and cannot be recalled unless reminded. Similarly, if you are talking to an LLM, the same can be expected. It also has a memory, right? So whenever you're conversing with an LLM, the conversation is stored in the currently active memory, or also called as the working memory. As long as the conversation is between the available memory space, you will not face any kind of hallucinations, or the LLM will not forget any detail that you are trying to convey to it. But once crossed, you can also expect the same with your LLM as well. Now, in a different way, you can consider this as follows. It's based on how long can an LLM carry out your current conversation without running out of memory or other scenarios hallucinating or getting bored and end up with small talks. Now, let us consider a relatively small conversation within the limits of the so-called current memory or working memory. Well, technically, this box here represents our context window, and in this case, the entire conversation fits within it. That means that when the LLM generated a response, it had it within its working memory. All good. So you just place a query, it provides a response, and again you ask a different query related to the previous query, and it gave you the final response, right? All good. Now, let's consider a longer conversation. I send my prompt and it sends me a response. Same way. We go a little back and forth for a few more times. At this point, the conversation thread becomes longer than the context window of this model. That means the queries and responses from the earlier in the conversation are no longer available in the model. It has no memory of them when generating new responses. The LLM can try to cope up, but how exactly is going to do it? That's when the term hallucination takes over the stage. Just like humans, the LLM needs you to leave some clues. Practically, it's making educated guesses, which can result in some wicked, irrelevant answers. So, understanding how the context window works is essential to getting the most out of the LLM. Let's dive a little deeper into this. Let's start with tokens. So far, we have a briefing on what is context window. Now, let's dive a little deeper and understand the technicalities. Each context window is measured using a scale called tokens. Basically, consider it to be a unit which is used to measure the size of the current or working memory. To better understand a token, let's take it this way. For humans, the smallest unit of information, we use to represent language is typically a single character, a letter, a word, number, punctuation mark, or many more. But for LLMs, the smallest unit is a token. A token can be a single character, a part of the word, or a whole word, or even a short multi-word phrase. So let's take a look at the example on my screen. So here I have written a small statement. Hi, welcome to Simplilearn, right? So here you can see the first box, hi, is a token. Second box, welcome, is also a token. Similarly, so on. Now, the tool that converts language into token is called as a tokenizer. Different tokenizers might tokenize the same text differently. But in a generalized way, a regular English word is represented by about 1.5 tokens. So let's say you have 1,000 words, then it may yield approximately about 1,500 tokens to store it. So various LLMs have their own way of tokenizing the inputs and outputs of the user, and they also have different sizes of context windows. Now, let's move on to the next important part of the session that deals with the context length, or simply, how does an LLM decide the context length? So now, the context length size. Now that we have understood what exactly are tokens, let's talk about how LLMs actually process them within the context window. Transformer models use something called as self-attention. This self-attention mechanism calculates relationships and dependencies between different parts of an input like words at the beginning and at the end of the paragraph. Self-attention computes vectors of weights where each weight represents how relevant is the given token is to all the other tokens which are in the subsequent positions. The context window size determines the maximum number of tokens the model can attend at once. Now, the context window sizes have rapidly increased. The first beginning LLMs had about 2000 tokens of length. The Gemini Flash now uses about 1 million tokens in its context window, and some models can handle even more. For example, OpenAI just came up with its ChatGPT 4.1 model that matches the Gemini's context window length, right? Similar to 1 million plus. That many number of tokens would allow you to talk to your LLM almost endlessly for 24 hours of time. But why do you even need so many tokens? Well, actually, there is a little gray area in the technicalities and the need for such a generous number of tokens. To understand that, we may need to understand how exactly an LLM uses its context window. So far, we have come across the query and response modes, but a context window isn't filled up only by the user inputs and model responses. It also includes a system prompt, often hidden from the users, that guides the model's behavior. Users may also upload images. Doesn't that ring a bell about Ghibli? Well, not just that, there are places where you upload information in terms of photos, videos, PDFs, basically all available media, some text documents, and even source codes. The model references all these during its responses, and most importantly, the LLM also relies on external data for your results, and it is used for retrieval augmented generation as well, or also known as RAG. This can also occupy space in context window. So with just a few long documents or some code snippets, a context window can fill up quickly. Some of you might have also encountered a message from ChatGPT that almost sounded like, enough for the day, you can come back tomorrow for the rest of your answers. Now, that brings us to the last part of today's session, which is an important one, which will discuss about the challenges of long context windows. You might think the bigger the context window, the better. But remember, with great power comes great responsibilities. The same way, the LLMs face challenges too. The first and the most obvious challenge is the computer cost. The computational requirements of the self-attention mechanism scale quadratically with the length of the input sequence. In simple terms, if the number of tokens doubles, the required compute power quadruples. That's because the model evaluates relationships between each and every new token and every previous token in its sequence. Now, the second challenge. Performance. Longer context windows also bring performance concerns. Like humans, LLMs get overwhelmed by too much details. They may start talking cognitive shortcuts. A 2023 study found that models perform best when relevant information appears at the beginning or end of the input. Performance trends to degrade when the model has process key information placed in the middle of long sequences. Now, the last and important challenge of all is the safety concerns. There are safety concerns too. A longer context window creates a broader attack surface for hostile prompts. Malicious content embedded deep in between the input could evade the model's safety mechanisms, increasing the risk for jailbreaking where the model executes harmful or unintended instructions. So now we have reached to the end of this session on the context window in LLM. Should you need any assistance, PPT, or any other resources used in this session, then please feel free to let us know in the comment section below, and our team of experts will be happy to assist you as early as possible. Until next time, thank you for watching and stay tuned for more from Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.